Hello everyone, welcome to my channel. Here in this video, we shall show a very important statement which is based on the properties of circle. The statement is, if AB and CD are two chords which are equal in measurement, and if when they are extended, then meet at the point E. Here in this figure, we can see this. AB and CD are extended to meet at the point E. Okay. If O is the center of the circle, it is given in the figure, then show that AE's length equals to CE's length as well as BE's length equals to DE's length. That means we have to show AE equal to CE as well as BE equals to DE. Okay. So again, the equalities are to be shown, right? So in most of the cases, we use congruency concept. So that's why we have to make a construction. It's clear to all of you. Which construction we have to make here? Join the center with this intersection point and also draw two perpendiculars from the center to the chords. Why center O is joined with E? Because we want to get two triangles for using the congruency concept. And why these perpendiculars are drawn? Because here also we shall use the concept that if the chords are equal, then they are equidistant from the center. And that's why distance means, perpendicular distance. So that's why two perpendiculars are dropped on AB and CD respectively. Let the perpendicular on AB is P and that on CD is Q. Clear up to this step? Now let's see how this construction helps us. Look, we have already got two triangles by this construction. One is triangle OPE, this is O. Another one is triangle OQE, right? Now by construction, P angle equals to Q angle. They are perpendicular. They are 90-degree angle, right? Okay. Next we get OE is the common arm by construction. And also we get OP equals to OQ because what I have already told you, equal chords are equidistant from the center. And these are perpendiculars by construction, so obviously they are equidistant. They are the distances. And so as the chords are equal, so the distances are equal. So this side, this angle, this side. Three conditions are obtained and so we can say the triangles are congruent. So let's first prove this congruency. So let's mention the construction first. O comma E are joined. From O, two perpendiculars OP and OQ are drawn on AB and CD respectively. Okay, now let's prove. I've already explained the proof. Triangle OPE and triangle OQE gives first of all OE, or you can say it as from triangle OP and OPE and OQE we get OE is the common arm So triangle OPE and OQE. From these two triangles we get OE is the common arm. Secondly, angle OPE equals to angle OQE. Both are 90 degree. By construction. Thirdly, equal chords are equidistant from the center. So OP and OQ are distances, right, from the center to the chord of the chords AB and CD respectively. So of course OP equals to OQ. OP equals to OQ. State the reason by it. As I have already told you that equal chords are equidistant from the center. Equal chords of a circle are equidistant from the center of it. Okay, here OP and OQ are distances of the equal chords AB and CD respectively from center O. From center O. Okay. So three equalities are found. So we can say triangle OPE congruent to triangle OQE. By which condition? By we have considered this side, and this angle. So right angle hypotenuse side by RHS condition. So they are congruent, right? So from this we can conclude that as the two triangles are congruent, PE equals to QE, PE equals to QE, corresponding parts of congruent triangle. So PE equals to QE. CPCT. Okay. Now, look students. This OP is the perpendicular on the chord AB. OP is the perpendicular on the chord AB, right? So obviously, this perpendicular will bisect the chord. This is also a very important property of circle, very useful property of circle. That if we draw a perpendicular from the center to a chord, then it always bisects the chord. So OP bisects the chord AB. So here we get, here OP bisects the chord AB. This is a property of circle, right? So we can say AP equals to PB equals to half of AB. Ticket number 1. Similarly, as the perpendicular OQ bisects the chord CD, so we can write CQ equals to QD equals to half of CD. Since AB equal to CD. So half of AB equals to half of CD. So from this we get, take it this one as equation number 2. From this we get as half of AB equals to half of CD. So this AP portion is equals to CQ portion as well as PB portion is equals to QD portion. Means all these four portions AP, PB, CQ, QD are all equal in measurement. So we shall use this equality to prove the statement. So we have already proved that AP equals to PB, this part equals to this part, and CQ equals to QD, CQ equals to QD. Now combining these two, we can say that AP equals to PB equals to CQ equals to QD. Why? Because as AB, since AB equals to CD, therefore half of AB equals to half of CD. And from this we get half of AB means what? AP and PB both are equal to half of AB, and CQ and QD both are equals to half of CD. So we can say AB equals to AP equals to PB equals to CQ equals to QD. All these parts are equal because these two chords are equal, so their half parts are also equal, and so this part equal to this part equal to this part, and all them are altogether equal also. And also we have found by proving the congruency that PE equals to QE. Now look students, we have to show that BE equals to DE as well as we have to show AE equals to CE. Now using this equality, let's see what we get. Since PE equals to QE, so if with PE we add AP, PE plus AP, then this AP should be added to the other side also to maintain the equality. QE plus AP. Now AP can be replaced by CQ, right? Because AP and CQ are equal. All these segments are equal in measurement. So let's take it as number 3. So we get PE plus AP equals to QE plus CQ using 3. So P plus AP means what? PE plus AP. Adding these two segments, we get AE, right? And QE plus CQ is what? This is QE, this is CQ. Adding these two segments, we get CE. So AE equal to CE. The first part is proved. Let's consider the second part. We have to show here that BE equals to DE. So by the same way, using this condition, PE equals to QE, we can show this like since PE equals to QE. So from these two equal parts, PB and QD are subtracted because we know PB and QD are also equal in measurements. So here we get PE minus PB equals to QE minus PB. Now this PB can be replaced by this QD. Therefore PE minus PB equals to QE minus QD using 3. So after subtraction we get P minus PB, PE minus PB will give you what? BE, right? Will give you BE, okay? PE minus PB will give you BE. So here BE will be left. And QE minus QD will give you DE. And that was the second part, that BE equals to BE equals to DE. That was the second part to be proved. BE equals to DE. So the second part is also proved. And hence the entire statement is proved. Hope the entire explanation is clear to all of you. Thank you so much.